first of all, let me ask, is there any questions in terms of the video projects? This is the time, if you have any questions, you can ask, I can explain. I have a grading scale posted on Moodle, okay? As well as the contents, 3 contents, right? You can pick. Any questions, anything you want me to talk about? I think the due is next week, right? This time next week, okay? Okay, any questions? Okay. So a video project, right? You have to shoot a video of you doing the project and conduct the experiment, as well as explaining the experiment, okay? To clearly explain. So also the correctness of your experiment and the explanation will be taken into account. Look at the grading. There are some part it will take into account the correctness. Okay. Make sure everything you say, everything you do is correct. Okay, that's, of course, that's the first thing, right? Then you probably need to balance the difficulty in the presentation. Okay, so balance the difficulty and the entire project as a, see, if it's too difficult to explain, then you may think again, because if you don't want to say something, you're not 100% sure. Okay, if it's not correct, I'm going to take points off. So be careful on that. But of course, if you choose too simple a project is, then you're going to lose some point on the difficulty, right? So that's a balance. I think probably you wanna keep. Okay. Okay. So I guess. Okay, I guess that's it. If you don't have any question, let's continue on the lecture for chapter 3. Yes.
On the rubric, you said difficulty is only 1 point. What do you mean by like?
Oh, there's 1 point from 0 to 1. I look at what your project. If I feel it's difficult enough, if it's, I give 1 point. Then if it's not too easy, I might give you between 0 to 1. Is that right? Is that clear?
Yes, sir.
Okay, so it's not much, basically. I try to say it's just 1 point. You know, if you can conduct a successful experiment with the topic, one of the 3 topics, okay, with good explanation, the difficult part, you know, I only use 1 point to separate, you know, for the projects from different, you know, projects. Okay. And the other thing is quantitative measure validation. Okay, that's the part I think undergraduate student to this point lack of. Okay, it's really, really important for your engineering career. You want to make yourself a good engineer, you have to, you know, when you do some study, do some analysis, you want to verify it. Okay, you do experiment to prove something. Sure, you can prove the existence of the, you know, the theory qualitatively, you know, but more importantly, you need to prove it quantitatively. For example, the theory tell you the equation, to tell you to calculate the surface tension. Okay, so you prove it. You prove the equal sign. That surface tension F equals to surface tension times the length. Okay, how do you prove that equal sign? So from your measurement, you can get your waterline length, for example. If you know the surface tension for water, for example, so you should be able to calculate that surface tension force from your experiment. But there's nothing verification there. With you just presenting that surface tension force you calculated from your experiment. It's just say, hey, that's what I measured. You didn't prove. Okay, you have to use a separate independent method to prove that force, it is equals to that amount you calculated based on the surface tension times the length. That makes sense? That means proof. You prove the equal sign. The right-hand side of the equal sign is sigma times the length. Okay, you get the value. That's your theory, basically. Okay, you measure the value. Okay, then you try to prove it. Okay, so how to prove it? You have to have an independent method to find out the force value. Okay, so that's the example. You don't have to do this. Okay, do this experiment, but you can pick your own topic, whatever. But think about it. You prove that equal sign is valid. Basically, that's usually what we call the quantitative verification. Okay, and does that make sense? Okay, I think that's a lot of students ask question, about this too. Okay, so okay, I think that's plenty enough. I think it's pretty clear, right, for the video project. We will have many video projects during the semester. It will be your 35% of your total of your grade. So that's a lot. If you can do good projects, hands-on, show me good hands-on experiences, then you probably will get a lot of points in your overall grade. Okay. Let me switch my screen. Let's continue on the hydrostatic pressure calculation. This is what we ended the last time, right? Did you see the screen, by the way? Okay, did I share it?
Still loading.
Okay, it's still loading. My computer is slow. I ordered a new one.
There it is.
Okay, hopefully I can get it soon. But you know, the purchasing process on the university is kind of frustrating sometimes. But hold on, let me see. Why you see the screen? Do you?
Yeah.
Why I don't see your videos anymore? I see my screen only. That's weird. Okay, doesn't matter. Let me put them separately. Okay, that's the equation I think I introduced the last time. I want everybody fully understand and completely memorize this method, this equation to calculate the pressure. Okay, so this is the equation derived from the basic theory, which is in the previous notes, which is from the between 2 points on the same fluid, right? P1 gamma 1 equals P1 Z1 plus P1 plus gamma Z1 equals to P2 plus gamma Z2, right? For each single fluid, you can have 2 points to compare. That's the hydrostatic principle. So if you have multiple fluid, you can add those equations all together become this. Let's review it again. So I just want you to memorize this method, okay? You have to have the starting point, the ending point for the problem. For example, this problem, you have a starting point 1 at the end of the manometer. Your ending point 4, that's the end of your system, which is on the surface of the oil in the tank. Okay, so you can directly find your end pressure 4 based on the beginning pressure 1 plus all the manometer readings in between. Okay, so that's the very easy method to do, but you have to remember. Okay, so let's look at this equation again. So your ending pressure P4. So hey, listen to me. If you see a problem like this in a test or in quiz, you need to give me those 1, 2, 3, 4 locations. Clearly draw it, write it on your drawing. Clearly write it on your drawing. Tell me what is 1, what is 2, what is 3, and what is 4, okay? If you don't draw this, even you do the 100% right for your solution, I take points off, okay? I want you to have a good habit as an engineer. Everything right, clear, neat, and everything you write down is 100% correct. That's the key part between an engineer and a regular person. Okay, very important. Everything you write down solving problem has to be strictly correct, 100% correct, and very neat and very detailed, so that other people can read, can understand. Okay, so that's a So one of the purposes I'm trying to emphasize. Okay. Okay, so 1, 2, 3, 4. So your ending point is P4. So put your ending point in the left-hand side of the equation, okay? P4. That's your goal. You want to solve for P4, the end point, okay? End point equals to the beginning point of pressure, which is P1. In this case, is 0. In some other case, might not be, okay? So put the P1 starting point first, okay? So then go from 1 to 4, go through 2 and 3, okay? So when you every time go through a next stop, you add a term in your equation. So P1, you from 1 to 2, your level goes down. So it's at, okay? Add the gamma of this fluid times L1, the level differences in between 1 and 2. Okay, every time you go through one fluid, add one term in your equation. Okay, and the plus or minus depending on the fluid goes down or goes up. Okay, can everybody remember this? Okay, okay. So from 1 to 2 goes down, so plus gamma m times L1. Then from 2 to 3, it goes up, the level goes up. Okay, in the air fluid, level goes up, then it's a negative minus gamma of air times the difference between the two levels in air, okay, L2. Okay, then you go from 3 to 4. Go from 3 to 4 in the third fluid here, which is oil. Then it's from 3 to 4 is going down, so it's a plus gamma oil times L3, the level difference between 3 and 4. You construct that equation 100% correctly. Okay, we have 15 of you here today. Everybody good with this? Okay, I want 100% all of you how to do this. That's the key. And then you're good. You can solve all those kind of static pressure problems in whatever system you have, no matter how many fluid there. Okay. Then you have this equation. This equation can be used to solve for one unknown. Okay. So sometimes the unknown is P4, but sometimes the unknown is something in the different level. Maybe L2 is your unknown, right? If you're given P1 and the P4, then you can calculate the one unknowns in this equation. Okay. Or even can calculate a gamma, right? A property of one of the fluid, maybe. Okay. So, okay. So continue on this. So let me give you one more example on the hydrostatic calculation. I think this topic is very important, and that's why I want to spend it today, spend a little bit of time today again. Yeah, this problem everybody hate. All the students hate this problem. It's an inclined tube. Okay. Every time students see inclined tube, they don't like it. But I really want you actually like it. It's a piece of cake to you at the end, I want. Okay, you have a pipe with flowing fluid. Okay, with flowing fluid. So that's bad, right? With the flowing fluid in the pipe, I don't have an equation for you yet. So far you haven't learned anything for the flowing fluid. Remember, this is chapter 3 is hydrostatics. Okay, statics. So if you have a flowing fluid, don't try to apply hydrostatics equation between 1 and 2. That's wrong. Sometimes if you're lucky, sometimes the condition right, you might get the same answer, but it's prohibited in our class. If between a flowing fluid 2 points, if you apply a P1 plus gamma Z1 equals P2 plus gamma Z2, no matter what kind of result you have, I will give you totally wrong. Okay, so with 2 conditions, the hydrostatic equation can be applied into the flowing fluid. Is when 1 and 2 had the same velocity, then there's no loss in the pipe. I don't think that's a condition you will have, okay, for most of the situation. Of course, there are always loss in the when the fluid start to flow, okay? So you can apply hydrostatics between 1 and 2, okay? Just keep in mind. So that's why if we want to know the pressure, we need the manometer down here with the shape like this. Okay, with shape like this. So this is called manometer. That's a simple, more simple manometer. Like I can draw some for you. Like if you have a, for example, next draw here, I will erase it later. Let's say, hey, I have a pipe. I want to know the pressure in the pipe. Okay, what people do, they can draw a hole on the pipe. Okay, then plus a tube here. What happened to the tube? You know, the fluid is gonna rise in the tube. Is that right? Because internally in the pipe, there's higher pressure. Okay, this is the simplest manometer, you know, right? How high, what is the pressure? Can you just measure the distance h? If you're given a h to 2 feet, can you find the pressure inside? What does that mean if it's 2 feet? What is the pressure? Let's say this is water in there. Water pipe. Manometer is a directly application for the hydrostatic principle. Okay, everybody, I want everybody to know how to do that. It gives you 2 feet of pressure. Let's say 2 feet of the height for the manometer. Okay, so what is the pressure? Can you do this? Can you calculate the pressure inside? Let's say pressure just this point near the entrance of the tube. Remember, this is a flowing fluid. Okay, your hydrostatic principle is not applying. It's not going to apply to 2 points inside the pipe. Okay, so in this problem, what are the 2 points you're going to use to apply for hydrostatic principle even? See, that's the first task for every problem I give you. You have to put down your locations, 1 and 2. It's required, okay, in every problem I give you. So yeah, where is 1 and 2? Where are 1 and 2's locations?
At h equals 0 and h, you said h equals 2 at the top?
Okay, let's say it's strictly speaking, you shouldn't say h equal to 0. H is a given value. So z dimension, this is the axis, right? When z equal to 0, okay, that's your first point here. Okay, when z equals to h, that's your second point. Okay, I understand what you're talking about, but it's not a correct way to say. In this class, I want you to say the correct language. Okay, does that make sense?
Yeah.
Right. Okay. Okay. So that's correct. Put down 1 and 2. Okay. So what is the question here? We are asked to solve the pressure, right? What is the pressure inside the pipe here at this location? Let's say at 1. That's the pressure what we want to find out. Okay, on the tip of the tube, it belongs to the pipe. Let's assume the pressure is the same along a cross section of the pipe. Okay, that's usually what we can assume. The pipe is basically small, basically along the cross section. On that cross section, we can assume the pressure is the same. So we can pick the point just on the surface of the pipe. Okay, so that's our goal, right? We want to calculate the P1. So what is P1? So let's say h is 2 feet. Okay, what is the P1 value? How do you calculate? Come on, everybody can do it, right?
Gamma H.
Yeah, gamma times H. Why it is gamma times H? It's P1 plus gamma Z1 equals P2 plus gamma Z2. It's start from there. Okay, you're good. Now you can directly spit out P1 equal to gamma H, but actually it's a hydrostatic principle like this because P2 is 0, open to the atmosphere, and the Z1 is 0. That's why P1 equals to gamma Z2, which is H. Okay, is that clear to everybody? That makes sense? Okay, so that's a simple manometer. Okay, again, this starts from the hydrostatic equation, right? Everything starts from that equation. That's why you need 1, 2. Okay, here it's simple because 2 is 0, then become P1 equal to just gamma H, right? If it's P2 have some value, it's different story. And okay. That good? This is the simplest manometer, but your boss gonna kill you if you do something like this in the piping system in his plant. Okay, you're gonna drill a hole on it. What the heck? And plus, it will be the tube gonna be so high, so tall eventually. Usually the pressure in there is gonna be high, right? Maybe high, maybe 2 atm, 14.7 psi, G, it would goes to maybe 30 feet if it's if it's the one actual atmosphere pressure inside the pipe. It could go probably 30 feet for the tube you need to. Do you have a 30-feet tube to put on the pipe in the factory? No, I don't think so. That's not feasible. This is really bad. This is on the theory only. On theory it works, right? Like this. Okay. But in reality, it's difficult to apply. But you see, 200 years ago, people want to do this, right? Let me erase this thing. So people have no choice at that time. You don't have the pressure tap, you don't have the pressure transducer, or those kind of electrical stuff like 200-300 years ago. But the industrial revolution starts, right? They have to know pressure, they have to know the fluid system. So what they do, people are smart, right? Some engineer design something like okay, so if this thing is too high, so if there are two restrictions, right? It's one is drill a hole on this, one is the tube will be too high to measure pressure. So maybe my boss allow me to drill a hole if we really need to know the pressures. But if it's too high, then it's difficult, right? So engineers are smart. So what they do is they, instead of drill a hole on top of the tube, they drill a hole on the bottom of the tube. And they put a U shape. And then put a fluid there. Let's put a very heavy fluid there so it won't push the fluid up too much. Okay, then you don't need a really long tube. Okay, you're going down we'll make a U shape and put some heavy fluid like mercury. Okay, so your internal pressure of the pipe only push the mercury a little bit because mercury is so heavy. Okay, so then based on the calculation deflection here, let's say H is the mercury deflection. Can you find the pressure here? Can you do this? By the way, this is the name. That's the name of this. You know what's the name of this? This manometer device. Actually, this is one of the invention early time. They have patent on it. This is called YouTube. It's not the YouTube we're using today, right? YouTube. We're using YouTube too. 300 years ago, people using YouTube. That's different YouTube. Okay, it's this U-shaped tube. Okay. So this is one of the manometers we'll use to measure pressure. Okay, so how? Let's say my deflection H is 1 inch. Okay. Mercury. How do you calculate the pressure of 1? Okay, you really need to do. This really need to be really familiar. You need to be really familiar with this calculation, and otherwise there's no hope to passing this class. Okay. So how do you calculate P1? Tell me. Let's say I can measure a distance A here. Okay, whatever value, depend on how long the device is, right? let's just use the letter A. Okay, how do you calculate? You tell me how to do. What's the first step? I really like to communicate with you, talk with you guys.
Number your interfaces or number your points.
That's right. Great, Josh. I like it. That's exactly right way. Number your interfaces, number your points. Okay, 1, 2, 3. I think obviously this one have 3 points. Okay, so P1 is our goal. So what's the first step? Maybe you're gonna do. Hey, you can do that method we just learned. There's the multiple fluid here. I don't want you to put 2 equations. Let's just do 1 equation. How about that? Anybody? Give me the equation. I just want 1 equation. Directly find out our P1. So equal sign. You see, I'm really like equation, right? Put the equal sign first. I'm gonna have equation. So what's in the left-hand side of the equal sign?
P1.
P1. Why is P1? That's the end point, right? Yeah. End point. Okay. So what is the first term in the right-hand side of the equation?
Gamma air.
Let's not to leave the complete equation, starting from the beginning point. I already marked 3 here, right? That's the other end, right? So the first term in the right-hand side will be the other end, the starting point, pressure. Although I know this case is 0, but not every case is 0. So have a good habit, write it down, okay? Write it down, the equation, write the complete equation first before you eliminate the terms, okay? That's always good because 10 years later, you're gonna come back to read it. You know, it's good for you to understand, still remember, or for other people to read, okay? Is that good, everybody? What is the second term?
Plus gamma of mercury times H.
That's right. Gamma mercury times 8. Why it's plus?
Because going down.
It's 3 and 2 and going down. Good. So next term. Let's say this is a water. How about that? Process fluid, just water. So in the leg also the water.
Minus gamma H2O times A.
I'm saying. That's it, right? So that's the equation. You calculate the pressure inside the tube, inside the pipe using this U-tube device. Okay. Is that good? Any questions? Everybody? All 15 of you? Okay. Okay. Good. So let's come back to our example. Okay. These are too easy, right? Okay, I erased it. I purposely erased it. So it should be in your mind now. It should be in your brain. Okay. Okay. So this problem is look like a more difficult. Okay. It look like, hey, this is the inclined tube. Okay. Let's say the deflection here in the mercury. This is still mercury. Say the deflection here is what? 1 inch. 1 inch deflection. H equals 1 inch. Okay, so this is the English unit problem. Okay, what is the gamma of, is that water? I think it's water. Okay, let's say this is the water there. By the way, what is the gamma water in English unit? 1.94 is the density, right? Times 32.2. So it's 62.4 pound per cubic feet. Okay, some number you want to remember. This is one of them. Gamma of water, 62.4. Okay, pound force per cubic feet. Okay. That's why I like the gamma better than rho g. Okay, especially in English system, this is more reasonable because pound force is a base unit in English unit system. It's become basically pound force per cubic feet. So density in English system is different, right? It's like slug, and 1.94 slug per cubic feet or something like that. It's a derived unit. So gamma works even better in the English system. Okay. Okay, so the question is, what is the piezometric pressure difference between 1 and 2? Uh-oh. That's piezometric pressure difference between 1 and 2. The question 2 is the piezometric head. Difference between 1 and 2. Okay, so that's our today's quiz problem. Okay, please take a paper, walk with me. Okay, don't worry about it. I lead you every step. Lead every step to you. Okay, so piezometric difference. Any questions in terms of the question? Okay, so the first step I want you to do. Okay, for question 1. The first step, step 1, write down the expression for this piezometric pressure difference. What does that mean in terms of mathematical form? Mathematical, let me give you a hint. So let's say PZ1 minus PZ2. Okay, so piezometric pressure, is that right? This is what piezometric, let's say we use PZ represent as piezometric pressure. Okay, PZ1, PZ2. Okay, expand this. Give me a actual equation for this. Don't worry about the whatever inside the manometer yet. Okay, let's say this is the elevation Z. Okay, let me give you some more information, dimensions here. You don't need the dimension yet. Okay, but in the book it says the distance between the high level to position 1. This is delta Y. The distance between 2 and 1. This is they call it Z2 minus Z1. Okay, so then the distance between the mercury fluid levels is H. H delta Y and the Z2 minus Z1. That's what in the textbook says. Okay, so the H is 1 inch. Okay, the first step, write down this. What is the PZ1? What is PZ2? I wanna, you say, hey, 2 terms in there minus 2 terms in there. Okay, mathematical expression for PZ1, mathematical expression for PZ2. Okay, I don't want you to calculate whatever, just put down. And the first step, I want you to write down also 3 and 4 here. Okay, so I write it for you. So just copy it on your paper with the figure there. 1, 2, 3, 4 clearly marked on there. Okay, so in terms of the 1 and 2, don't put anything on 3 and 4 yet. Okay, I just wanted the expression for PZ1, the expression for PZ2. Did we talk about the piezometric pressure in previous classes? Right? we introduced that, right? Basically, we said the hydrostatic principle is basically said the piezometric pressure is a constant inside of one fluid. Okay. Two terms. Piezometric pressure is something plus something, right? I want everybody can write these two.
Pressure plus gamma Z.
Okay, you already tell everybody.
Oh, sorry.
That's all right. It's okay. I just this is the half point quiz. Okay, I posted on Moodle already, so it's only 5 points. It's not really. I'm not quizzing you much. I'm just want to lead you to go through the whole process and you know, as an example. So P1 plus gamma. Tell me what gamma of Z1, right? And the gamma of water. Okay, so you write the piezometric too. Okay, on your paper. So see, I'm trying to convey something different in comparing to other classes you probably take. Okay, my opinion, between an engineer and a handy person. Of course, engineer has to be a handy person. You know, if you choose mechanical engineer, you probably is already handy, right? That's what you're good at. Okay, but between a professional engineer and a handy person is when you talk about something in an engineer in their mind, the first reflection is a equation, expression, mathematical expression for that term. Why a handy person, regular person without an engineering degree will think about this, what is reality, what is this, what is that? Okay, you probably need to know that too as an engineer, but the additional thing you're better than the regular people is you know a mathematical formation or equation or expression for whatever thing we talk about. Okay, that's what I try to convey here. What I want to make you a better engineer here. Okay, so when we talk about piezometric pressure difference, when you first see this problem, you're so confused. Oh, what the heck is this? Piezometric pressure difference. What is the piezometric pressure? But think about this. The first reflection for you is just write down, okay, what is the mathematical form for the piezometric pressure? Write it down. Okay, so if you know the mathematical form for piezometric pressure, basically follow this is just to solve that mathematical form. Okay, so that will make your life much easier when you deal with real-time engineering problems. Okay, rely on the math. Let math translate the physical problem. Okay, so let me just give it to you. P2 gamma water Z2. Okay, so this is your entire goal for the problem here. Okay, so you basically translate this question into these 4 terms in the right-hand side. Okay, everybody follow me? That good? Easy, right? Understandable, right? Basically, you translate your question into these 4 terms in the right-hand side of the equation. So your goal is to find out the 4 terms in the right-hand side of the equation. Then you solve the problem. Is that right? Is this the strategy acceptable? Okay, so now, good. So from a very awkward sentence, it's piezometric pressure difference between 1 and 2. From a very awkward sentence, we translate that into a mathematical equation. So good, that's our first step, okay? We successfully translated, that's good. Then you're halfway through, basically. Okay, so, okay, now, so in this problem, you see gamma water is given, right? Z1, Z2, I don't know. It seems like it gave me Z2 minus Z1 here, but it didn't give me the exact value. Okay, think about this. If the problem didn't give you exact value, maybe in the later time, maybe it can be eliminated. Okay, right? Otherwise, like h, it give you 1 inch. Okay, look at this, h equals 1 inch. If we need it, it will give you a value. Okay, here I see the problem statement say delta y here, and the z2 minus z1 here. It just didn't give you exactly value, so don't be worried. Don't worry about it. If it didn't give you exact value, maybe there's a chance later it can be canceled. Okay, so gamma wz1, gamma wz2. See, if you rewrite this, it become P1 minus P2 plus gamma water Z2 minus Z1. Is that right? Okay, you should feel good because Z2 minus Z1, hey, actually given Z2 minus Z1, this just didn't give me the value. Maybe later it can be canceled or, get rid of. Okay, gamma water is a property. Okay, so good thing is I group P2, P1 minus P2 here. So now, next item, next line is yours. Give me an expression P1 minus P2. Going through the manometer. Okay, you cannot directly get the equation between P1 and P2 in the fluid, in the pipe. It's flowing fluid there. Whatever you learned so far doesn't apply. Okay, but see, your goal is to find out this expression, right? Stick with your goal. Gamma W Z2 Z1, let's leave it later, okay? P1 minus P2, you have to have an expression for that. Okay, P1 minus P2. Give me the expression going through the manometer. You cannot directly going from 1 to 2 inside the pipe flow because this is fluid dynamics. So hydrodynamics. So you don't have any equations for that. Okay, so forget about it. Okay, no equation directly from 1 to 2. You have to go through the manometer part, which is hydrostatic. By the way, do you agree this is hydrostatic in the manometer? There's no flow. Okay, you see every flow, whatever flow, possible flow, is being stopped by the mercury. Okay, you're shooting down, the mercury stopped you. Okay, so in the both legs with the mercury, everything here, no fluid, no flow, no movement. Okay, so inside the manometer leg is hydrostatic. Do you agree? So go through the route from 1, 3, 4, 2. Go through that route is hydrostatic. And we have weapons. We have equations to solve hydrostatic problem. So give me an expression for P1 minus P2. Okay, so next step. Step 2. This one, I leave it to you. Okay, I give you maybe how many minutes you want? Just one line of equation. Okay, give me. Okay, let's not do too long. 2-3 minutes. How about that? Okay, maybe some of you already did. Seems like. Okay. Write down the equation before you put in the value. Don't put the value again. I just leave the substituted value to the last step. Okay, because you may be able to cancel those gamma Z2 Z1s, those things later. Okay, so just leave a complete expression for P1 minus P2. Okay, don't read the textbook. I use totally different ways as the textbook. If you copy the whatever on the textbook to this, I give 0 point. Just follow my steps here. Okay, open up your head. See your face. That means you're done with this step. We can continue. And turn on your video, please. It's a quiz. So. Again, use the way we just did, right? Starting point, ending point. And then you rearrange it, put the P1, P2 in one side of the equation. Okay, so there will be an expression, P1 minus P2. Let me move to the next slide. I think I have a typo down there in the previous page. Gamma water times Z1 minus Z2, right? Yeah, Z1 minus Z2. It's not Z2 minus Z1. What the heck was I thinking? Okay, but anyway. Okay, so the step is I want you to do is P1 minus P2. Find out what is this. This is for grading, okay? A little bit done. It will be a long expression, right? Based on this drawing. Just one line. Just put a one line. Don't need to continue. Okay. Let's continue all together. Okay. The next step. Substitute your P1 minus P2 into this equation. And give me a, then simplification. Rearrange it. Give me a expression for what is PZ1 minus PZ2 equals. Okay. So this is the 1 point. Let me see 1 point, 1 point. Okay, let's have 2 points here. Okay, the substitution is 1 point. Substitution and the rearrange. Okay, some term can be canceled. Then final solution. 1 point. Okay, this is the 4 points. Let's stop in here. I have another point is to convert piezometric pressure to piezometric head. I just want everybody to get the 5 points. I'll go through this, okay? After you've done the substitution, then putting the value and do the calculation. Okay, I need to give you the mercury property. Gamma of mercury. Let me give it to you. Okay. So gamma water is, I already said it in the previous slides, 62.4 pound force per cubic feet. Gamma mercury is 847. pound force per cubic feet. Let's make it a little different. Okay, hold on. Let's put the gamma mercury slightly different. Let's say, let's still use a specific gravity. S mercury is 13.5. Okay, so I guess I leave it for you to calculate the gamma of mercury. Okay. Okay, so these are total 4 points. Okay, you know how I grade. Okay, that P1 minus P2 expression was the most, 2 points. Okay, then after the substitution, simplify the equation for PZ1 minus PZ2 equals something. That was 1 point. The final answer is 1 point for the PZ1 minus PZ2. Okay, did everybody done with it?
Could you go back to the previous page just for 1 second real fast?
Okay, yeah.
I need to see the,
Oh, you mean the drawing? Yeah,
yeah, the drawing.
yeah,
So
yeah, yeah, sure,
No,
sure.
I didn't copy on everything.
Okay, yeah, I'll keep this on. So from the equation, you know that pressure only changes with the elevation, right? Only with Z. Doesn't matter the orientation, then the slope or angle, whatever. It seems like it doesn't matter. It's only Z's, right? In this problem, it could be Y, Z, and the H always in the vertical direction. Okay. Is that good? Everybody getting the answer? It's fine. I'll give you a couple more minutes. Everybody getting there? Feel free to ask questions. So I'm not testing you. I'm just wanna if everybody learn this. Okay, you have a question, go ahead and ask. Let's talk about it.
Professor,
Yeah.
you said P1 minus P2 being wrong. Like, did you refer to like the numerical value that was within it?
No, I just wanted one equation. Don't put the numerical value. I don't like numerical value. One equation we just learned, right? Starting point, ending point, from starting point to ending point, right? The ending point equals the starting point plus minus, go down, go up, remember? Okay,
Yes, sir.
I want you to write it down like that, okay? Then just move one of the P to the left-hand side, become P1 minus P2 equals to a long expression. Don't put value there. Don't substitute value, don't. I don't like numerical value. Is that clear? William, right?
Yes, sir.
Dylan, right?
Yes, sir. Thank you.
Okay. You're welcome. You're welcome. Is that clear to everybody? Okay. Make sure that step correct. 2 points. Okay. That's the most. The step was the most point. Okay. I like the expression P1 minus P2 equals a long expression correct before you substitute. Then the substitution and the rearrangement was another point, okay? But get the 2 point first. Okay, seems like everybody is still doing, huh? Okay, good. I'll give you more time. Again, if you have some different idea or different way, don't do your way. Just try to do my way, okay, this way. This is the most efficient way. And it can apply to more complicated problem without you thinking too much of physics even. You're just following the steps.
Did you give us Z values to plug in for the final answer?
No.
Oh, okay.
No, that's what I said. It didn't, the problem statement didn't give you Z as well as delta Y. It didn't give you delta Y either. So likely, you see, likely for those kind of problems, you don't need the Z and you don't need the delta Y because it didn't give you the value. Okay, if you need the value, it give you like H, it give you 1 inch. Okay, so likely if you do it correctly, it will be canceled. Okay, if it's not, that means something wrong. Switching back and forth is 2 pages. Just let me know if you need to see the other page. I can just turn it on. Any questions? We have 30 minutes to the end of the class. We need to finish this one in 30 minutes. Any question?
I have a question.
Yeah.
So you just want us to write the equation, right? PZ2 minus PZ1 and then piezometric head equation, right?
That correct equation for 1 point. Yeah, okay. So I wanted the P1 minus P2 equation correctly for 1 point. Okay, oh, for 2 points. Okay, then substitute that P1 minus P2 into this PZ1 minus PZ2 equation. I wanted the expression correct for another point. Does that make sense? Did that clear to you?
Yes.
Okay, then after that, substitute the value, get the numerical answer. That was the last point here.
Okay.
Okay.
So we don't have to.
Stick with the letters. Stick with the letters. I want you to use all the letters, then cancel out all the letters before you substitute value. Okay. Actually, you need to only substitute the value in a very short expression, so very easy. But if you substitute too early, and it's so complicated.
Okay.
Okay. That is the engineering way. I found so many years teaching, I noticed you guys the too keen to putting value there. Okay, no, putting value there for this problem too early, then every turn is there. Nothing be canceled. It's so complicated there. Okay, I see some of you already done. Look at me, that means you're done, right? Okay, even if you're not done, I need to talk about the last point here. The last point is to convert piezometric pressure to piezometric head. You don't need to go through the whole process again. You just do a directly conversion. Okay, do you remember what is the conversion? The piezometric pressure is P plus gamma Z. This is piezometric pressure. Piezometric head is P divided by gamma plus Z. This is the pressure PZ. This is HZ. So that's a directly conversion from PZ to HZ. So you have both PZ, PZ1, and PZ2 here. So directly convert to HZ1 minus HZ2 with the conversion effect. Okay, then the value, calculate the value. You have directly have the value, right? PZ1 minus PZ2. Okay, so here you can do a conversion and calculate HZ1 minus H2Z2. That's the last point here, 1 point. Okay, these are the total 5 points. Okay, you have 10 more minutes to submit. It's open Moodle, the submission site, quiz 3. Okay, so if you've done it, take a picture and submit. If you submit, you can go. That's it for today. Again, earn those 5 points. Okay, if you just directly give me an answer, you get a 0. Okay, these are the 5 points. Okay, so what I grade the problem. Same thing as other problem when I grade your quiz or test or final or whatever. So these are the process. I want everybody, before you leave the class today, totally learn this topic, okay? Pressure calculation, piezometric pressure, piezometric head, okay? So should be good. Look at all the homework problems. If you're good with this one, you shouldn't be have any problem with those problems in the side, okay? You have 5 minutes. The summation side will close on 45. Okay, so submit at least 1 or 2 minutes early. Make sure everything goes through.